Okay class, going to take you through questions 5 to question 11 from exercise 5.08 in the textbooks, the mixed trig problems. So question 5, the angle of elevation of the top of a flagpole is 20 degrees from where Tom stands a certain distance away from its base. After walking 80 metres towards the flagpole, Tom finds the angle of elevation is 75 degrees. Find the height of the flagpole. Like most of these questions, the secret to success is how you set out the question. Looks like it's a triangle. We're going to couple of assumptions here. We're going to assume that the flagpole is perpendicular to the ground, and so my drawing tool's not working. Why is my drawing tool not working? Oh, that's not fair. It's because my pen was upside down. Nice one. Okay, let's begin. So if we draw this out, he's standing a certain distance. Tom's standing down here. Here's the flagpole. He walks. Angle of elevation is 20 degrees. He walks 80 metres towards the flagpole to another location, and he sees that the angle of elevation from that point is 75 degrees. He's walked 80 metres, and we need to determine the height of the flagpole, which is over here. So there's a couple of different ways we can attack this one. I'm going to just go for a purple pen here. A couple of ways we can attack this is we could use this triangle here to work out the hypotenuse of this right angle triangle. At the end of the day, we want the height of the triangle. So what I'm going to do, I'm going to figure out this side of the triangle here using this information from over here, and then we're going to use right angle trigonometry to work out this last bit. So for this triangle here, we've got it 20 degrees. Its opposite this side I want to find out. Let's just call that x. I've got an 80 metre distance here. We don't have the opposite angle up here, but we could figure it out because we've got 75 degrees here, which means supplementary angle here of 105, two angles on a straight line, and then inside this triangle we've got a 20, a 105, that's 125, which means we're going to have a 55 degree angle up here. So we've got a side and its opposite angle and a side and its opposite angle, two sides, two angles. That is the sine rule. So we want to find out what x is. X over sine 20, that's going to be equal to 80 over sine 55. And just to save us a bit of time, we'll go straight away and calculate that. It'll be 80 times the sine 20. The sine 20 will come across. I'll just bring the calculator a bit closer. And on the bottom we'll have sine 55. And that gives us, that hypotenuse is 33.4 metres. I'll just check the accuracy there. Yeah, 0.40. Okay, so now that we've got that, we've got the right angled triangle. We want to know the height. We've got 33.4 and we've got a 75 degree angle down the bottom here. So we've got a sine ratio there, so sine 75 equals h over that, so we'll end up just taking a little bit of a shortcut here, so 33.4 times sine 75, and that should give us the height of the flagpole. Get that calculator back out. 33.4 times sine 75. For a final answer, it's almost 32.26. To the nearest metre, it'd be 32 metres. So that's question 5. If we move on to question 6, triangular field, has sides 85 and 50. B is on a bearing of 65 degrees from A, and C is on a bearing of 166 from A. Okay, so first thing I'd suggest you do in a question like this, because it's talking about bearings, is draw up a north, south, east, west grid. Going to get a different colour pen. Might actually go back to the slightly thicker pen. Okay, and so because everything here is from A, we can assume that A is in the centre of this diagram. Now B is on a bearing of 65, so B is going to be up 65, maybe here somewhere. So I'm just going to, for now, just draw in a dashed line. B is going to be somewhere on there. We're going to have 65 degrees in here, and down here, probably more importantly for the future, we're going to have 25 degrees. We can then see we've got a point C on a bearing of 166. So again, I'm just going to draw a dashed line down here, somewhere in this vicinity here. If it's 166, that's 76 degrees past 90, so this angle here will be 76 degrees. We then can have a look at these two bits here. B was 85 and AC was 50, so along that's 85, and this one was 50, so I mean it's not too important that that's drawn 100% accurately, but what we have now is we have a triangle. We want to know this distance from B to C. Oh, that's a terrible B. From B to C, and so we've got an angle inside the triangle with two sides either side. That's going to be a cosine rule. So x squared equals 85 squared plus 50 squared minus ... You can do the rest from there. Again, another example of getting a correct diagram, and obviously yours will be a little bit neater because you're not using a tablet and a pen. On to question 7. Question 7 is a triangle. Two similar triangles in fact, because both of these triangles, this smaller one and this larger one, share a common angle. The parallel sides here, we've got 65 here, and we'll have a corresponding 65 here, and similarly these two here will be the same as well. We need to find the value of h. And that should be easy enough for us. In fact, because of this fact that these two are 65, all we need to do is figure out the length of this side of this triangle, and if we add it to 4.1, that'll be h. Should be pretty straightforward. We have a side and its opposite angle. We have a side that we're looking for and its opposite angle. So there wasn't too much to this. So sine rule, x over 65, sine 65 equals 3.9 over sine 54. If you go ahead and rearrange that, you'll get the value for x, and then h will be 4.1 plus whatever you worked out for x. So that's question 7. Question 8, a motorcycle and a car leave a service station at the same time. The motorbike travels on a bearing of 80 degrees and the car travels 15.7 kilometres on a bearing of 108. Now this one's a little bit different from question, what was that one, 6 that we did earlier. The next bit of information, until it's on a bearing of 310 from the car, so we've got to be real careful here. I'm just going to change my pen here so I can draw up our north, south, east, west grid. I'll go back to my red pen, that was a nice pen. So the bike's travelling 80 degrees, so I'm just going to do a dash line there for now. That's the motorbike, I'll just call that motorbike. The car's travelling bearing of 108, so that's slightly below 90 degrees. And it travels until the bearing of the motorbike from the car, so assuming the car is here, the motorbike will be on a bearing of 310 degrees, so it'll be back in this direction. Because if the car was here, for instance, 0 or 360 would be straight up, so 310 is going to be back in this direction. So I'm just going to finish that up there. Because I've used a red pen there, I might just change that to black. Because now what we can do is say, okay, don't know how far this is. We know that we've got 10 degrees here because this was 80 degrees a bearing, so this is 10 degrees in here. We know that this was 108, so that'll be 18 degrees in here, and that gives us a total of 28 degrees in that angle. We also know that the car travelled 15.7 kilometres. And then lastly, we know that this bearing here, now if it's getting a little bit messy here, I do apologise. If I draw a north, south, east, west grid here at where the car is, we know that this angle between there and there, because of the 310, was going to be 50 degrees. Which means that this whole angle here would be 40 degrees, because that's a 90 degree angle. We also know, because this north and this north are parallel, that this being 18 degrees up here, imagine we get one of those alternate Z angles there, this here will be 18, and we said this was 40, so that will leave us with 22 degrees for that angle there. So we have 28 here, 22 there. How far has the motorbike travelled? Well, that's that distance there. We have its opposite angle now. We have this angle here, this side here, and the opposite angle here. 28 plus 22 is 50, so that'll be the obtuse angle of 130. And now it's just a matter of using the sine rule. X over sine 22, 15.7 over sine 130, and I'll leave the rest up to you. Question 9. Submarine is followed by two ships A and B, 3.8 kilometres apart, with A due east of B. If A is on a bearing of 65 from the sub and B is on a bearing of 205 from the sub, calculate the distance from the sub to both ships. Okay, so let's draw up a north-south-east grid again, and let's assume that the submarine is at the origin. Okay, get my trusty red pen out. A and B due east, so they will be on a horizontal line here. B is on a bearing of 205, so B is down here somewhere. Because this is 205, remember south is 180, so we'll have 25 degrees in there. And I'll get a different pen, why not? A is on a bearing of 165, so we're down here. This will be 15 degrees. Obviously the diagram is not to scale, and that will be a horizontal line parallel to that east-west line there. What other information do we have? A and B are 3.8 kilometres apart. Okay, and the other key bit, because they are due east, this line here is perpendicular to that north-south-east line, which makes these two triangles right-angled triangles, which is really handy for us, because that's going to mean, because we want these other two angles in these triangles, this will make this 75 and this will be 65. And so it's find the distance from the sub to both ships. Let's call this, just call it little b, let's call this little a, and you could use the sine rule there. B over sine 75 is 3.8 over sine 40. I'll just set that one up if we were looking for b. B over sine 75 equals 3.8 over sine 40. and rearrange that to find B. A will be the same. The only difference here, this side will be the same, but this angle here, because A is opposite 65, will be the difference. I hope that one helps. Question 10. A plane flies from Dubbo on a bearing of 139 degrees for 852 kilometres. So again, we'll set up our bearing here. So a plane flies from Dubbo. Let's put Dubbo in the centre because we're flying from Dubbo on a bearing of 139. So it's going to go down here somewhere. Being 139, this means that this is going to be 49 degrees. Not sure if we need this one or this one just yet. Then turns and flies on a bearing of 285. So from this point here, imagine there's a north, south, east, west here. 285 will be back almost the way it came. I mean, might even be down here. We might just have to, if that's 49, now 289 would mean, yeah, it's going to be down here, because 285 is 15 degrees just above west. And if that's our west line, it's going to have to be it then turns and flies on a bearing of 285 until it is due west of Dubbo. Okay, so here's Dubbo, and it's going to have to keep flying until it's way over here. Now, I knew this would happen. The purple pen, it's hard to see this diagram, but that's essentially the diagram you end up with. And again, on your, I hope you can draw a better diagram than that. The key bits here though, this distance here will be 852. Now this angle here is critical for us. Obviously that's a right angle. 49 there, that one will be 41 degrees. So this whole angle here will be 131. Now we said this was 285, so this little angle here is 15. This angle here, because this was 49, this will be 41, which means that this angle in here, which we need, I'll just draw it out here somewhere. 15 plus 41 is 56, which will leave 34 degrees in here. So we've got 131, 34. If we need this, we could get it. What do they add up to? 165. So that's going to be 15 degrees. Funnily enough, it's going to be alternate to this one down here. We've got 852 there. How far from Dubbo is the plane? So we just want this. And again, that looks like a pretty straight up and down sine rule. X over sine 34 equals 852 over sine 15. On to the last question. A rhombus, A, B, C, D. Okay, so a rhombus is just a square without the right angles, just tilted slightly. All sides are the same, 8 centimetre sides. It will go ahead and label A, B, C and D. And BD is 11.3. Find D, A, B. So this angle here, well, that's pretty straightforward because both of these sides are 8. So essentially we've got, oh, that's a terrible triangle. We have 3 sides and a missing angle, so it's got to be the cosine rule. Don't forget, for the cosine rule for angles, it's going to be a squared plus b squared minus c squared over 2ab. Put your shift cos on your calculator first of all. A and b are going to be the 8s, and c is equal to 11.3. As long as you get that, you're pretty safe that you're not going to make a mistake there. I hope that helped out with anyone who had trouble with those questions. The next video will do questions 12 through to 18.